好。So I've been working in Alibaba for over a year, and I started to work on containers after I joined Alibaba. So I am an active contributor now. My partner is Lantao is here. Hello everyone, I'm Lantao. I joined Google in 2015, and I worked on Kubernetes. I'm the maintainer of Cloud Native. And also have colleagues from Dog, Thomas, Derek. This is a small meeting room. It's also my first time seeing so many participants. And the session has 35 minutes, and Liu and I will speak 15 minutes each, and then we will leave for 5 to 7 minutes for questions. So let's start. So for the first 15 minutes, I would like to focus on the integration, because this is still new, different from Doc, so I will focus on how to use it. And for more details, we will look at the status quo of container D. Container D is from Doc company, and by the end of 2017, it became part of CNCF. It has very good development for 2 years, and it's also very fast, and there are many clients. And this is now the 5th graduation project of CNCF. And now a lot of large companies use container D. We have GKE and IKE working on IBM Cloud and Alibaba, Microsoft, AWS. Last month, a colleague from eBay said they're also using Container D. So again, there are many clients of Container D. I believe Container D is a mature software. It can provide a high-performance runtime engine, but not many would transfer from Doc to Container D. Container D will not provide some client-facing features. For example, image building. Container D is more integrated into a large system. So if you want to merge from Docker to Container D or Container D CI, you may need to understand its architecture and how it's run, and it can create some container platform. Now let's look at this architecture. This is a well-drawn diagram by Derek. Now a lot of cloud platforms adopt Container D. On the bottom, you see that Container D support Container Runtime, Kata. So there's more than run. You can also select other types of functions. So in this diagram, you can see a lot of modules in Container D. Let's focus on Container D API. It's a standard sys design. It provides a gRPC API, which can be used to create various functions. For example, Docker engine and coach, etc. So says that Container D would like to be integrated into large system. So this is client, and our service side we have different modules such as content and runtime, etc. These modules can maintain some low-level resource, for example, storage format, such as overlay. It can also do non-spacing. It allows different clients use the same container D. Because they have less space, they are separated. In addition, Container D also has very important function, snapshotter. It's similar to graph driver, but it's more capable. It can provide some easy-to-operate portals. Moreover, Container D also provides Prometheus API. You can use it to monitor Container D's own process and the progress of the containers they manage. And Liu will talk about CI. He will give you more details. So a brief summary. Container D can provide API service. You can use your own API to achieve a lot of things, but it's different from Docker, which can do pull image, which is a large API. So Container D doesn't do that. In Container D, we have smart client. Back to what I just said, the side of the Container D server. It supports low-level resources. The API is wrapped by gRPC. So on the client side, you can use a low-level resource, including some container resource. So on client side, you can do anything. For example, installation or backend to frontend. Let's look at just a small example. When we want to deploy image, it's not a call of one API but 4 API. For example, deep service, content service, snapshotter, and the image. This image may be different from the image we usually talk about. It's used to manage data. It's used to connect to snapshotter and some preliminary data. So on client side, a lot of things are done, and the portals are quite small. So these services can be reused and grouped together. So the client can call the image and portal of API. Generally speaking, I don't want to call Container D as microservice architecture, but there are clear boundaries between different modules, so the client can do a lot of things on the client side. For example, if I want to change the position of the current process, you can do this without changing the code in backend, so it's very flexible. So the API can be used or operated with on client side. Of course, on service end, there are also a lot of work to be done. For example, if I need a new format of image or security container such as Kata, how do we integrate them? Because we can't just maintain one branch, because it will lead to high maintenance cost. So in container D, any component is a plugin. So how do we understand this? So I said the modules have clear boundaries, so they can be grouped into different plugins. So in the code library, there's a dependency graph to be maintained. So based on the method of registration, the plugins can be defined and extended. So back to my topic, how do we integrate third-party service? One method is to create a new container D. So container D provides you with a common entry point. So you can start your go round file and add the entry point and plus the third party service. So this document can create your own container D binary. So very quickly you can connect with third party. But it may be more troublesome. So the second method is external. So it's an open source method. You don't need to do orchestration. And we support two plugins. One is Proxy. The other is about a container, and Liu will give you more details. So first, Proxy plugin. Simply speaking, container D can forward the request from upstream to the third party. So maybe more users would choose snapshotter. So currently only snapshot and the content are supported. So it's a forwarding service. So you should implement APIs on third-party plugin. And with this their service, the information sent to container D, which is read and connect to your server. And then the upstream request is forwarded to the third-party server. That means you don't have to change any code on the service. And there's also Runtime plugin. This is also a plugin. So how was it used previously? When we integrate Runtime or Kata, we would add configuration for Runtime. Docker can use container D to generate a shell script and a rapid service, which may look like run C, but it may lead to some problems, and also you will face some limitations. So now we have Runtime API. So if your own container can implement API, it's okay. And then API is binary. So your API should also follow the naming protocols. So when you start your server, the server can be found. So API is looks like this. So let's see Windows Container and Kata all implement this API. So it looks like this. IO container the .runsc.ve, and it will be turned into container Shim. Runsc, they will seek for the binary. So this will integrate with the third-party security container. So that's about integration. And I'll hand over to Liu. Hello, Liu Lantao. Today I would like to talk about Containerd Kubernetes engine, the application, and I will cover Containerd and the integration with Kubernetes. We have defined an interface Kubernetes, called it Kubernetes CRI. So it's a set of functions defined. If runtime can do these functions, it can achieve integration with Kubernetes. So we have found that there were a lot of runtime, including Containerd. We hope we want to support different runtime. So we defined this interface. After 2 years development, there are more runtime. And we'll focus on Containerd, IO, and the Docker streams is used to support Docker. And the community, some of the people in the community would like to remove this. So in the future, we'll use the CRI to do integration. And also had Rumby, the precursor of Kata, the Fracti and the Pouch from Alibaba, and Rocket, Birdlet, etc. So this is about CRI. In order to integrate with Kubernetes, we need to implement CRI. So we have this Containerd CRI plugin. Find the code in this link. And 1.1 version, we built this into the Containerd. So if you have Containerd binary, it's supported. It doesn't matter if it's self-built or use Docker, which is part of Containerd. You will have CRI support loading. In April 2018, it's production ready. So I'll show you this. Containerd type. So under every list, you can have a lot. You can have a lot of test cases, and most of them are red. If they are red, then in Docker they're also red. So you can see my desk.
So now it's production ready. So when we compare with previous integration with Docker, you can see there's no Docker Shim. We only have a kubelet and containerd integration. So in terms of stability and performance, it will improve a lot. This is a simple architecture. So Kubernetes tells us I want to pull image, and CRS tell us we want to have pull image. Then we use containerd to pull image, and then kubelet want to start pod, and then we set up a pod environment, and then when we set up pod network, we use CNI plugin, CRI plugin. Then the pod is ready. This is a comparison with Docker Shim performance. So you can see, for example, 105 pod batch startup benchmark, and also 105 pods management overhead benchmark. Then we will see the components resource usage. The reason for using 105 pods is that because the default support pod number is 105. The red one is containerd and the red one is Docker Shim. Basically, all better. We recommend that gradually we can shift it to CRI because Docker Shim, Docker support. In our plan, we will remove from Kubernetes, and I don't know whether we will duplicate or not. But we need someone to maintain it. Then how can we shift from Docker integration to CRI containerd, this kind of new CRI integration? For containerd, it's very simple. If you have Docker 18.05 installed in your machine, we already have containerd, and they have as long as you install Docker, you already have container. So when you start Docker, you can also enable CRI. Then you add several flags. Then you should not talk with original Docker Shim, but with the containerd, and you should ensure that you have a CRI plugin. Then if everything's ready, then it's done. Then you already have containerd. So actually we're still using Docker, but a new version of Docker. This is the integration of containerd with Kubernetes, and we hope that you can gradually shift your production environment into this one, because most of the functions will be here, as I pointed. And for Docker, we need someone to maintain it. If not, then a lot of new functions will not be there. And for GKE, GKE is Google Kubernetes engine. It's hosted Kubernetes service provided by Google Cloud. And basically all the cloud have this kind of service. Containerd 1.1, last year it was beta, and not long ago we have used containerd for master node. Because I'm on vacation now, so actually during my vacation, they can reach GA. And probably at the end of this year or next year, we will use containerd for all the nodes. For old nodes, it will be in Docker. Just now, I talked about Containerd and Kubernetes integration, and Containerd is used in GKE. Actually, in GKE, when we use Containerd, we can do a lot of things. Now, let me briefly introduce GKE Sandbox. As we all know, although container is very convenient, but in terms of security, still there are some problems. So we use a host Linux kernel. If there is a bug, then they may escape from the container. Then they will store your data or influence your production environment. So we already have a lot of previous problems. To solve this problem, GKE has done one thing, that outside the container we want to add another layer of protection. If you have strong demand for isolation, you can have that. We are based on gvisor. For gvisor, a brief introduction. Actually, it's an open source by Google, and it's a sandbox technology based on user space kernel written in Go. And it is also OCI conformant, run as C. So your application is in user space, and this call is through it to have virtualization. So as a result, you cannot directly access to host kernel. So as a result, you can have two layers of security isolation. To support gvisor in Containerd, we need to make sure that gvisor is different from runc. On the left side is runc, on the right side is gvisor. It's different. You can see gvisor have its own kernel, and in runc for Containerd, they suppose your application is run on host kernel, so they may directly send message to you, or when you exit process, you can directly observe it. But for gvisor, all the container process is run on the gvisor kernel. You cannot directly get this information from host kernel, so you need to talk with the gvisor kernel for this information. So in this way, for Containerd, they need different behavior to treat gvisor and ordinary runc. So we need to have a layer of abstract. So under this abstract, they can have different behavior. To solve the problem, we have a discussion with Containerd community how to solve it. For the benefit of Containerd, it has a lot of interface, and we go through every interface, and we find that Shim is the right layer. So we decide in Shim level we have an abstract. So we have Shim V2 for gvisor, sending signal or monitor, application exit, or taking monitoring stats. Previously, we cannot do it. Now we can abstract it under Shim V2, and for gvisor, they can also use their own special implementation. When we have Shim V2, actually, we can do the gvisor integration. We have an internal Shim, and all these behaviors that cannot be handled previously can be handled now. And now Shim V2 is now a standard. For example, Windows is doing so. So if you have your own runtime, you can also use it. This is at the containerd level to support gvisor, and at the Kubernetes side, we also need to make some changes. When we start pod, we need to tell Kubernetes it will be run in gvisor, and so we have an API called Runtime Plus, and for different runtime, you can have define a runtime class, and then when you start pod, you can use this runtime class. So we have a gvisor runtime class, and at the CRI level, we need to send this runtime info. So we say this pod is using this runtime, and then we need to configure this runtime is correspondent to what Shim. So we add this configure here. When everything is done, then we from Kubernetes ATI to every interface to containerd support, all these are connected now. We have an animation here. Anyway, it's not important. So you can see here, end to end. And user said, I want to create a pod and use gvisor, and Kubernetes can see it, and they use CRI create a pod, and they will use gvisor. And then we have a configuration here. If you want to gvisor what you should do, then you need to use Shim. Then we need to start the Shim. Then Shim knows how to manage gvisor container and how to communicate with them. And the same method can support Kata. And for GKE Sandbox, last year it was alpha, this year May beta, and we still cannot use it in China. But anyway, if you use G-Cloud, it's like this. And have a quick recap. Kubernetes containerd integration is ready for production use. We recommend you to shift. Otherwise, in the future, maybe 2 to 3 years later, if you have not shifted, you may have some problems because Docker Shim, a lot of functions will not be updated, and you cannot have the security fix or bug fix, or you can shift to other CRI. And also GKE container support is beta, and in the future it will become default, and all the nodes will be containerd. And GKE Sandbox is built on Kubernetes plus containerd and plus gvisor. And the containerd is extensible. We have a long list of interface. So whatever you want to do, you just look at the interface and you may find something that is suitable for you. That's all. Thank you. So we are just on time. We have 5 minutes for questions. Can you share with us when you shift from Docker runtime to containerd, what area should we pay attention to? I guess you all heard the question. What we need to pay attention to is that because all the things are in containerd, Docker itself have the all the container have state. So all this is moved to containerd. Then you cannot see it in Docker, and the image you cannot see it anymore. So Docker and Kubernetes will just share underlying containerd. Kubernetes do all the thing, and Docker will know, and whatever done in Docker, Kubernetes will not know, because Docker have different application scenario with Kubernetes. We don't want to have overlap. And how can we do debug? Actually, in upstream, based on CRI, we have interface called CRI Carto. It's similar to Docker CRI. This is based on CRI. For example, previously when you run Docker PS, you can see a lot of container. Now, for Kubernetes, we also have some automation, and when you run Kubernetes, you can see a long list of containers, and we cannot exert metadata, so you cannot know what the containers are for. And then in containerd, all these containers are redesigned, and you can clearly see the container name and also in what port they are. Please use a microphone. In Docker, all the functions you want to have, you just change to create Cardo. Because they are using the same CRI interface. In Kubernetes community, there's another runtime called CRI. It's also compatible compared to containerd. What's the advantages and disadvantages? How do you suggest to users to use containerd or CIO? Actually, it's your own choice. Because previously, when asked by other people, we will just say, we hope that this one is not important to you. Including Cardo, it's a standard tool. No matter you use containerd or CRI, it's the same. So it will support both runtime. For Kubernetes user, you don't need to care about whether it's containerd or CRI, whether when you run or containerd or CRI. We hope the operators OSD will decide. For example, we want to GKE, we will use container optimized operating system, and we will still use Docker. For Run Hat or ISU SE, they will use CRI. So we hope to reach a status that you can make your own decision. It's not important. As for the two project itself, containerd have Google, Ali, Docker, Microsoft, IBM are maintaining it, and Cryo Run Hat is maintaining Intel. And they also have a lot. You can take a look by yourselves. When we eliminate Docker-D, a lot of functions will be missing. For example, quota management, log locator. How do you view this?
Just do this based on Kubernetes. So whatever Kubernetes supports, we will do. Of course, the scenario you mentioned has the same bias. 有人已经发音对吧？对，这个事情，我觉得是可以的，就是我们可以在 Node 先从 Node 开始做，再往上。 next door, how to compare the two. I've heard they have community numbers. I don't know how you respond to that. We work with the team direction, but I'm not managing as a team. These two of us are used. But they're different use scenarios. We use Together because Together is Google open source. Another important reason is that GKE, including all the solutions around VM, each node is VM. If we use Carter now, then it means virtualization is embedded. But without embedding the virtual machine, Google doesn't have this scenario. So Kubernetes is very good. It doesn't need to embed virtual machine. There are different platforms. Some don't need virtualization. So this is our use case. Different vendors have different use cases. Of course, we support Carter as well, but we want to solve this issue of virtualization. So again, both are useful. I just now see Containerd support x86 and ARM. And so how long between its commercialization? I don't know.
Yeah, so the ARM support, so what's the gap of the ARM version?
ARM 支持 Containerd 本身我们还没有这种支持。我们还需要就是 CI 配置。那我们现在支持的是多架构。如果你要在创建多平台的镜像，那么 Containerd 就可以去帮你创建，还可以运行。我们还会有这个，将来会有这种支持。So, thank you very much.